when one has an XT diagram, no matter how complicated it is, you can always decompose the XT diagram into two situations. Either the curve is curve down, like this case, or curve up, like the right side. So now let's talk about what's the property of an object's motion for these two kind of um, shape, right? For these two shapes of the XT diagram. So first, let's talk about curve up. So we have a bottom here, and we know that from XT diagram, if I draw the slope, then I get the velocity of an object. So that's the Vx, let's say Vx1 at position 1 here. And at position 2, we also draw a slope, and that is Vx2. And according to the slope's direction, we know that this one is negative, and this one is positive. And these 2 points correspond to 2 time instant, t1 and t2. And t1 is less than t2, or t2 is a later time. Okay, so the average acceleration is then given by Vx2 minus Vx1 divided by t2 minus t1. Okay, so that's the average acceleration. And since we know Vx1 is negative, Vx2 is positive, so this ratio here is going to be positive. So that means that the average acceleration at this curve up situation is positive. And then we can also think about when point 2 approach point 1. So when we have the limit of 2 approaches 1, then the average acceleration becomes the instant acceleration. So this acceleration will keep the positive sign is still positive in this case here. So the curve up situation, we have velocity of an object goes from negative to positive. So the acceleration at any point, not just point 1 or point 2, at any point here is going to be positive. So let's write down AX positive for this kind of curve up situation. So now let's look at curve down. Let's look at curve down situation. We do the same thing. So let's pick a point of 1 here and draw velocity, then we get Vx1. And we pick another point here, we draw a slope, we get Vx2. And Vx1 is positive, Vx2 is negative. And again, t1 is less than t2, right? T2 is later time. And if we calculate the average acceleration for this curve down situation, we get Vx2 minus Vx1 over t2 minus t1. But since Vx2 is negative and Vx1 is positive, so this average acceleration is going to be negative. And again, in the limit 2 approaches 1, we have Ax average approaches Ax, which is negative. So you can write down here for this curve down situation at any point, we have Ax being negative. So now we already talked about curve up and curve down. So you have to connect these two kind of shape using one point. Right? One point is going to be in the middle of this curve down and curve up situation. So one example is here. So you have a curve down and then curve up connected by this point. And this point at this point we actually have a transition. So ax is going to be 0 here. So this point here is transition. Right, transition between curve up and curve down. So at this point you have ax equals 0. So this case corresponds to in the mathematics we have second derivative equals 0. Okay, the second derivative of the xt diagram equals 0.